Hello everyone, my name is Priyadarshan and our teammates are Samarth, Kiran and B C Srikanth. Uh, Today with respect to the operating system subject under the guidance of Professor Shivan Gowda sir, today we are going to discuss about parallel sorting with child process in Windows and Unix environments. To start, the goal of this project is to efficiently sort a large dataset of 10 million integers by utilizing parallel processing. We focus on splitting the dataset into small subarrays, assigning each subarrays to a child process for sorting, and merging the results into a fully sorted array. This method demonstrates the power of parallelism, especially for handling a large data processing tasks. We implemented this project for both Windows and Unix systems, leveraging platform-specific inter-process communication techniques like create file mapping and mmap. Now, let's discuss the problem we aim to solve. Our objective was to divide the dataset into 10 subarrays of 1 million integers each. Sort these using 10 child processes. The final merge the results into one sorted array. Key features of this implementation include efficient process management, shared memory for dataset exchange, and an optimized merging algorithm. With that overview, I will pass it on to the next person to explain how we achieved inter-process communication and detailed implementation. Thank you.
Instructions: program setup, process.c. Write a program process.c that generates a 10 million random integers and stores them in array. Divide the array into 10 sub arrays, each containing 1 million integers. I will pass the responsibility to my friend Samar to continue developing the program further.
Thank you, Kiran and Priyadarshan. Now, the code has been given. Let us understand the code. Here we have included windows.h and stdio.h for libraries. Also, we have been started by uh, void sorting of array with integers taken as int array and int size. Next, we have also included the main keyword where the program actually begins. And let us see what kind of variables we have included. That is, one is argc and argv. Now, we have a condition that arg, if arg is less than 3, then the program should print usage size and the whatever the array gives the size. Next, the int start index variable is declared with the condition given for the arg1 and arg2. For one is for index and one is two is for size. Next, handle map file where we'll use hashing techniques, and for the access of full maps we use that. If false, then if the condition is false, then the text will be printed where the located file is located. And now let us see what condition has been given. Let me scroll down a bit. Next, the condition is if map file is empty or null, then the condition should print could not open file mapping. And also we have a condition where if anything happens, then it will return 1. Now, int shared array is an variable where we have been created, and int map file has been used as the keywords. And we have also used some functions such as file map all accesses. And now we have also used the another condition for if when shared array is equal to null, then also it should print the similar condition what the up was there for this whole array for this variable also. For one, it's hash file, and second one is for also the shared array. Now let us see for what sorted array has been declared. Sorted array and sorted array, because we need to call the sorted array variable, and we'll follow with through the conditions such as start index or and array size. Now cleanup. This is used for the cleanup while we need to close or empty the hash and shared array, what the elements we have been added to the arrays and hash mapping. And finally, we return 0. This void start sort array is nothing but after the emptying, then the further continuation of sorting of array should be continued. So we use this part of code. Thank you.
Sorting with the child process. Implement 10 child process to sort the sub-arrays in a parallel. Use the create process API for Windows or for a Unix based systems. Each child process should receive one sub-array and use sort.c to sort it. Entire process communication IPC. Implement IPC using a shared memory. Windows, we use create file mapping to create a shared memory region and mapping view of a file to map it into the address space of the parent and child process. Unix, use a mmap for the shared memory functionality. Explore alternative APC method like pipes or files if shared memory is unsuitable. Merging sort arrays. After all child process complete sorting and the parent process merges 10 sorted sub-arrays into the single sorted array. Implement an optimized merging algorithm to minimize time complexity. Perform measurement. Measure and compare sorting times for a parallel sorting versus single process sorting. Log execution times for each child process and merging the process. Additional requirements: ensure each child process only sort its assigned array, handle edge cases like sorting large numbers and duplicate values, use close handle to properly release resources for a create process, create file mapping and the map view of file, ensure gracefully termination of a child process, deliverables, provide the process code for parent C and child process.c. Include documentation explaining the choice of IPC method. Example: shared memory versus file-based sharing. Steps in the merging algorithm. Performance observation and efficiency analysis. Provide the executions times logs for analysis. Next, I will pass to the Samarth.
Now, as Kiran explained, now let us understand how parent works. Now, parent in the child process, we have been created an array and inputs, and then we have cleaned, and the further process will be continued. Here in parent process, we will include Windows.h because as we have been provided with the Windows operating systems, let us understand how it has been done in the Windows. First, we will include stdio libraries and stdlibrary.h, and here we will study about limits. In we are defining a size array of size some numbers and defining number of uh, number children number as 10, and we are also defining child array size as array of size and divide, which is nothing but that the whole number divided by 10. Now we'll see how we'll add an function named as generate random array from the child parent, and we'll pass on some arguments like variables, arrays and size. Next, further, we will also create an void function named merge arrays, where we will be merging all these variables into arrays. Now, the main function starts where the actual code starts, where we will create a main array and give a malloc dynamic memory allocations where we can alter the allocations or variables when we need after the code of executions. Now, if we have used a condition where we have if not equal to main array, then we need to print fail to allocate memory. And if generation array is used, then we will pass on two arguments named as minimum array and array size. Handle value. Similarly, we have created a map file if conditions. Similarly, if the file mapping object is not done, then it should print that could not create a file mapping. And let us scroll a bit down. For condition, and we will initialize I is equal to 0, and we'll also give a condition where is I is less than equal to num children. And there is always be an increment after the children if the I is less than children variables. Scroll a bit down. Similarly, the if condition used and the output will be same as failed to create the child process. And further, with all the child process, when it completes, we have given another conditions for where if it's less than, then the further it should increment. And we have also used here a keyword infinite, means when we are doing that for a single object, then it should move on with infinity. We'll also add some process. Now we'll use the variable merge array, and we'll pass on the conditions such as child arrays, num children's, result arrays, and array size. Similarly, we'll clean up the arrays where we had done in child process. Here also we'll clean up the mapping or hashing mapping, and the shared array, main arrays, and result array we'll free up, and then we'll generate a random array and then store it. Then again the loop will be continued. Thank you.
Thank you, Samarth. Now I will explain key point of support code from the view of parent.c. Create shared memory with the create file mapping. Maps this shared memory with map view of file of access in both the parent and child process. Launches the 10 child process using create process with unique command argument specifying each child subarray starts index and size. Wait for child process to complete with wait for single object. Merge sort array after all child process have finished. Now from the view of child process.c or child program.exe, access the shared memory using open file mapping and map view of file. Receive the assigned array segment indic, ind, receive the assigned array segment in indices via command line argument. Store the assigned segment and the child starting ಮಾಡ್ತೀನಿ child.c. Now from the point of view of child process.c or child program.exe, assigns the shared memory using open file mapping and map view of file. Receives the assigned array segment indices via command line argument. Store it assigned segment and then terminates. This skeleton structure provide a clear outline of approach handling child process creation, memory sharing, and array segment sorting. Thank you.